Okay guys, this is the 2015 circular motion question. Very hard to tell it was a circular motion question to start. So what you have is a skier of mass n kilograms is skiing on a hillside and reaches a small hump in the form of an arc. The word arc would indicate circular motion, arc of a circle. Okay? Circle O and radius 7. So you know straight away that 0 to A is 7, 0 to B also a gap of 7. Realistically, what you're doing is it's part of a larger circle. Okay, so that's what you're trying to picture. Okay, now OA and B line the vertical plane, and OA and OB make angles 22 and alpha with the vertical respectively. Skier's at A, so he's going from A to B, so I'd say that U would be equal to 8. The skier loses contact with the ground at point B. Find the value of A. If you're talking about contact with the ground, what are you talking about there? I think we're talking about reaction forces, aren't we? Or values supporting the weight of your skier. Okay? It's a vertical motion question, vertical circle, so what are our two equations that are in play?
Conservation of energy and central.
And conservation of energy. Okay? You can see from your marking scheme that the first one up is the conservation of energy. Okay, so we're just going to write down a half mv1 squared plus a half, I'll say not a half, mgh1 equals a half mv2 squared plus mgh2. Now, what is the height above ground and what are we declaring as to be 0? I say we just declare this part here to be 0. You get it completely right if you declared this to be 0 as well. Just two completely different systems, both yielding the same results in the long term, okay? But for the time being, we're going to do this, okay? So what's his height? What's the height in the first part then? So I'm looking for this height here, or the this line here, the blue line. What can you tell me that is? By alternate angles, guys, that's 22. The radius is 7. That, in my opinion, says 7 cos 22. Okay, it's the blue height. Alright, there's your 7 cos 22 right there. Okay, so it's a half. Your mass, you're skiing at 8 meters per second. You're getting your mg 7 cos 22. Okay, equals. Now the next thing you're looking at your second one. It's going at speed v here. That's no bother. So it's just a half mv squared. Now what is your second height? Second height you're looking at is you want to get this line here, and this line obviously being, call it the second blue line, alright? So that would make alpha this one here by alternate angles, and that would make that A. Anybody?
A cos.
Still alpha cos, so it's 7, isn't it? So 7 cos alpha, and there's your first equation done and dusted. So you've already completed the conservation of momentum. Okay. Now the next thing you're going to do is your centripetal acceleration. You can see the phi squared there. Okay, so you're going to do your centripetal acceleration. Okay, so I'll just get rid of this for a second. So centripetal acceleration is Fc equals mv squared over r. You're going to go back to the top, and you're probably going to get rid of a lot of the work you've already done there, because that was all for the conservation of momentum. Now you're looking at the centripetal one. So what we're going to say here is that mg once again works directly down. What way does r work? Directly up. We want it along the line of action. This is our target line. We want it to fit that line perfectly, okay? So, what do we need to do with mg then? Do my usual trick, I reckon. Will this work? Let's find out. Okay, would you agree that's alpha? Why is this one alpha? Okay, why is this one alpha?
Because the one at the top.
Yeah, it's alternate with the one at the top then, isn't it? Or you could just call it you could call that like angle B, and you could work it out that way as well. Now what does that make this component here is I'll highlight it in yellow, this component here is the part that's parallel to this here. Okay, so what way does that go? It's acting diagonally left down. So what value do you think it is? Huh? mg cos alpha. So, and when you flick out your marking scheme, you realise they're working with mg cos alpha. So you're happy enough with that. So Fc, which is mv squared over r, is the acceleration going towards the centre of the circle. Going towards the centre of the circle is your mg cos alpha, which is here. But then you got to take away your r value. Yeah? At the point of contact, what happens when you lose grip? R equals 0. So now you have mv squared, and what's our r value? 7 equals mg cos alpha. Okay? Now, and oh sorry, there's an m up there as well. Once we have two equations. This one here in yellow, this one here in blue. Now, the thing about the blue one is, we'll just work on the blue one for a second. Half of 64? 32. I'm just going to call that 7g cos 22. I'm not going to do anything with that at the moment. A half mv squared, no bother there. Well? Oh, the m's are gone. Thanks. And then what's the other one? 7 cos alpha. So, what we're going to do next is, I reckon, isolate phi squared on both of them. So, get rid of that m, get rid of that m. Phi squared equals 7g cos A. Then, to hell, I'll just sub it in, won't I? Might work out quicker. That'll be 7 over, equals 7 over 2. Over 2g cos alpha. Is that a g as well?
Yeah.
I think I lost it up here.
Yeah, because it's from MGH.
It's from mgh, so that's a 7g.
Yeah.
Sorry, 7mg cos alpha. So there was a g up there. Okay, so there definitely should have been a g up there. Okay. Now, finally, to get rid of this all, multiply that by put everything over 2 again. So that's 64, 14g cos 22. Call that 14g over 2. So 14g plus 7g, 21g cos alpha. So we're going to have a bit of cos inversing to do. We're going to get cos alpha equals 64 plus 14g cos 22 all over 21g. Then we're going to cos inverse our answer, and it's my hope that it comes out to be 21.7.
Yeah.
Perfect. And there you go. Okay, good.